Hello again, geometry. This is chapter 12, information on inscribed angles is what we're going to talk about, and what is an inscribed angle, and what does that look like, and all the things that go along with this type of angle. So we have a central angle. We have the idea of a central angle. I'm going to add a page in here, insert blank page real quick, and I just want to talk about some of the stuff that we know. So we have our circle. Let's get a nice circle. We have a circle. That's not so bad. That's a pretty good circle for me. And then we have our angle that exists right here, angle 1, and then we have the arc AB. And our rule was that angle 1 is equal to the arc AB. So I know if angle 1 was 88 degrees, I know arc AB would also be 88 degrees, and vice versa. So now we're going to add in to this picture, we're going to add in this piece of information. We're going to add in, and oh, let's just do this. This is called a central angle. And this is called the intercepted arc. Intercepted arc. And in this case, our intercepted arc is a minor arc because it's less than 180 degrees. I could label it with 2. Now, the inscribed angle is what you would get if you put the vertex on the circle somewhere and you extended it out like that so it hits at the same 2 points. That red angle, I'm going to call it angle 2. Angle 2 is called an inscribed angle. And this video is specifically about that type of angle. What are the rules that go along with an inscribed angle? Well, just visualizing it, just looking at it, do you think angle 1 is bigger than, smaller than, or less than, or equal to angle 2? I mean, if you had to compare the two, just visually looking at them, which one's bigger? Yeah, obviously 1 is bigger, right? So 2 gets smaller. So we're not going to be able to say that angle 2 is equal to the arc, because we already know angle 1 equals the arc. That's 88, that's 88. Angle 2, it's not equal to the arc, but there is a secondary rule that goes with it, and that's the rule we're going to talk about here today. What is the rule about an inscribed angle? Okay, well, I'm going to call this angle, well, let's just call it angle 2. Angle 2 is inscribed. And the rule is inscribed angle, okay? And the rule is equal to this. An inscribed, S-C-R-I-B, inscribed angle is equal to 1/2 the intercepted arc. So whatever the arc is, that inscribed angle is half of it. So let's say this is about 80 degrees. Here are the things that we could come up with. I'm going to go back to the blue real quick. I'm going to say, oh, one thing I know is this central angle right here. I'm going to call it angle 1. I know that angle 1 would also be 80 degrees. But in this section, I would also know angle 2 now. Angle 2 is equal to 40 degrees because it's half of the arc across from it. So if you're given an angle like this, and they have to hit on the same spots, by the way. I mean, they hit the same arc. But an inscribed angle is half the arc. It's also half of the central angle because of that relationship between the central angle and the arc being congruent. Okay? A couple other theorems that go along with this. Here I have 2 central angles. I have a green one. I'm going to call this angle G. And I have a blue one, or a red one. I'm going to call this angle R. And the rule is this. If those 2 angles hit the same arc, then those 2 angles have to be equal. Some quick math. Let's say this was 100. Well, this would be 50, and this would be 50. They would be equal arcs. And the rule is inscribed. I can't spell inscribed today for some reason. let's try this again. Undo. Inscribed, inscribed angles, which intercept the same arc, are congruent. So in this case, angle G would be congruent to angle R because they hit the same value, they hit the same arc. That's an arc rule. Another arc rule. If the inscribed angle right here, if that inscribed angle, if its endpoints here, the arc that it hits, if it hits a diameter, so you can see it goes through the center, if that's a diameter, what value do you think that would be? Well, that's 180. It'd have to be a right angle. It actually makes a right triangle. We have a whole bunch of right triangle stuff that we can do on this one. So I'm gonna put I don't know, put angle 1 in there, okay? And then I'm gonna put I'll put AB as a diameter, AB. So if AB is a diameter, AB is a diameter, then the rule is angle 1 is 90 degrees. It's that easy. And we have a, I'm gonna add this in. We have a right triangle, just to remind yourself to do all that right triangle stuff that we've been able to do. And the last one's kind of a unique one. It's kind of a little bit different. And the rule is this: if you can put a quadrilateral, if you can inscribe a quadrilateral in a circle, and I'm going to put like some angles in here, 1, 2, 3, 4. If you can do that, if you can inscribe a quadrilateral in a circle, then there's something here. There's those angles right in there, 1, 2, 3, and 4. Those angles, they have to add up to 360. We know that. But there's another rule that goes with it, and the other rule that goes with it is the angles across from each other have to be supplementary. So I'm going to put angle 1 plus angle 3. Angle 3 have to add up to 180 degrees. That's a rule. And angle 2 plus angle 4 also have to add up to 180 degrees. If a quadrilateral can be inscribed, if it's an inscribed quadrilateral, I'll just put quad, opposite angles are supplementary. And that's a rule. So with that, let's do some example problems. Let's look at some different types here. So I have some pictures here, examples on finding angles. This would be part of the notes. You could download the notes sheet on this. I think this was chapter 12.4, something like that. Find the angle notes. You could follow along on this if you are able to, or you could press pause and draw the picture if you want. But I'm going to go through these pretty efficiently. So this is find the angle. So I have some angles in here. I have some congruent chords. Ooh, I got a couple diameters. Let's go. So first of all, angle A. Well, angle A is inscribed. Let's see. It hits this. Well, an inscribed angle is half the arc, so that's 50 degrees. Angle B. Well, if that's 100 and I have a diameter, it means I have 80 degrees left over there. Angle B is a central angle, centered, so B is equal to that. So that's 80 degrees. Angle C. Well, 80, I have congruent chords, so I'd have to have 80 there. Also, I could do vertical, 100, 100, 100, 100. This would have to be 100 over here. If you remember vertical angles, because this angle, this central angle has to be 100 there, so its vertical angle would have to be 100, and then the arc across from it would have to be 100. So C hits that arc 100, so C would have to be 50, and then D hits 100 right here. Well, half of 100 is 50. So you can see the math is pretty easy on some of those. You just go through it and see if it's a central angle or an inscribed angle, and you go with it. Okay. Next one is that quadrilateral one. The opposite angles are supplementary. So if that's 85 the angle across from it, these two add up to 180. So I'll do 180 minus 85. And that's a 95-degree angle. 95 degree. The B, I can do that in my head. That's 88. Arc, XYZ. XYZ right there. Arc, XYZ, and I put a little arc over it. Oh, here is a inscribed angle. It's 85 degrees. That 85 is half of whatever that is. Or I can go the other way and I can double it to get back to the arc. So 85 times 2 is 170. So XYZ is 170. And then WZY. I think I'll probably do the same thing here. W to Z to Y. So this right here, from W to Z to Y. Well, that B right there hits that arc. So if I have B, I'll double 88. And I get 176. And I don't think that's drawn to scale because 176 is definitely under 180, but that looks like it's over 180. So I didn't draw it to scale, but those are the numbers that you get. Two more. This one. All right, so A, O, diameter, A. Okay, that's got to be a right triangle right there. So A has got to be 90 degrees. B, chord is congruent, chord is congruent. So if that is 60, that is 60, and B is half of 60, or 30. C, well, half a circle, 60, which means I have 120 left over there because a half of a circle has 180. So I have 180, 60, and 120, and then C is half of 120, which is 60. D, half of 60, which is 30. And X to Y the short way because it's only two letters, arc X to Y. Arc X to Y, well, if those are both 60 and that's 120, that leaves 120 left over right there, and we'd have it. Okay, last one. Last one's kind of a funky picture, but it works the same way if it's a tangent and that's coming out. It's still half the arc, and if I go like this, that angle A is going to be half of 142. 142 divided by 2, 71, is that right? 71 degrees. So angle A is 71 degrees. Angle B, well, forms a linear pair with A. So I'll do 180 minus 71, and I get 109. So this angle is 109 degrees. And then 109 degrees. And then XYZ is that distance. And if I have 109 there, I would double it to get to the arc. 109 times 2 is 218 degrees. Okay? All right. One other type of problem that I really want you to be able to do, I'm going to add, insert a blank page here. I'm going to add it. There will be a problem at some point that looks like this. Maybe this is 82 degrees, and this is 5x minus 3. And it's probably not going to work out even because of what I did. I just made it up. So an algebra problem, one of these. Well, the rule is the angle is half the arc. Angle is half the arc. That is the overriding rule. An inscribed angle is half the arc. So when I do algebra problems with this, I start by writing this down, and then I just fill in values off of this over into that equation, just like we've done with some other equations. So my angle, well, that's 82, equals 1/2 of the arc, and the arc is this 5x minus 3. You could definitely distribute. Distributing will give you decimals, or I'm going to multiply both sides by 2 to get rid of that fraction. And I get 5x minus 3 is equal to 82 times 2 is 164. I'll add 3, and I get 5x is equal to 164 plus 3 is 167, and I could divide by 5. 167 over 5, I got 33.4. X equals 33.4. When you hit an algebra problem with this stuff in, if you see x's, I would start by writing that down and then start filling in your values and going with it. All right, that's it. Good luck.